So in the last class, we were discussing that how from a cost function we can retrieve back the production function, and we were discussing some properties of the CES production function as well, right? So anyone having any questions on those? Anything conceptual or any in the numerical part of it? Any doubts from anyone? Okay, perfect. So essentially, if I just recap a little bit for all of you, in case you all have forgotten a little bit. So in the last part, we had started our discussion on the CES production function, right? Which is represented by this. And basically what we saw was that this CS production function has two parameters. One is your rho and one is your delta. And depending upon the values of rho, you get the different forms of production function. So we discussed the two cases. If rho is equals to -1, so this production function becomes similar to the perfect substitute type. And if rho is equals to 0, then we basically get the Cobb-Douglas production function. But obviously, we had to do a slightly long calculation because the idea was if you're simply putting rho equals to 0 in the expression, you were getting an indeterminate form, right? Which doesn't have any finite value. So since it doesn't have any finite value, from an economic perspective, it doesn't make any sense, correct? So that's why we require to check that in the limiting sense. So today, in this context, we would want to continue with our discussion on the CS production function. But before doing that, I would like to introduce one more concept to you all, which is known as the elasticity of substitution. Okay, this is usually denoted by sigma. And just to put a little bit of context to this, we find elasticity of substitution of a production function. Okay, this would make the sentence complete. So that means in order to start with this concept, we will be assuming that we are given a production function of labor and capital. All right. And obviously, when we are actually writing a production function, now many things might be falling in place for all of you. We obviously need to put a very reasonable assumption, I would say, that the MPL and MPK are positive, correct? This has to be the case, no matter what kind of a production function you define. All right. And we will be taking the rest of the things later on. So by definition, sigma is basically, the definition states, it is percentage change in the K by L ratio divided by percentage change in marginal rate of technical substitution. Okay. This is what the definition of sigma states. Percentage change in K by L ratio divided by percentage change in MRTS. Okay. Does anybody remember what was MRTS? The definition? Anyone? Anyone on this call? Okay.
Yes, sir. It was like what will the change in the labor to change in the cap? Like what will the change in the capital regulation?
Hmm, couldn't follow you exactly, Abhishek. Okay, let me just reinterpret this once for all of you. MRTS अगर हम लोग graphically देखते हैं, then it is the absolute slope of the isoquant. Okay, this is what it is. And the formula or definition of MRTS in that case will be MPL by MPK. Okay, this is what it is. The absolute slope of the isoquant, and this is what we MPL by MPK. Right? Now, uh, think of it in this way कि आपका जो MPL है, it is MPL is basically this component, right? Del Q by del L. This is MPL, correct? And MPK is del Q by del K. This is your MPK. Okay. So it is basically the ratio of the marginal productivities. All right. Intuitively, अगर हम लोग सोचे कि if I am drawing a particular isoquant, let's say, if I'm drawing a small diagram like this, in order to draw isoquant, I will be taking labor on the horizontal axis, capital on the vertical axis, right? And I will fix a level of output and I will draw isoquant. Okay. So the slope of the MRTS is basically the slope of the tangent at a point. Correct? All of you agree to this? Can you please confirm me with a yes or a no? Slope of the isoquant matlab kya? Slope of the tangent at that point. Correct? Can all of you confirm me? Yes?
Yes.
Yes, sir. Yes.
Correct? So अगर if I ask you that ये सब तो ठीक है, ये सब आप graphically you are understanding all this. What is MRTS? It is basically the rate at which you can substitute labor and capital, right? Technologically feasible rate of substitution. Correct? अगर आपको आउटपुट लेवल फिक्स रखना है, so whether you operate at this point A on the isoquant or this point B on the isoquant, आप level of output same रख रहे हो, correct? But the rate at which you can substitute labor versus capital is what is different. And when you are at point A, the rate of substitution is as actually very high because the tangent is steeper. You can substitute more labor for very little capital. But when you are coming to a point like B, you can the marginal rate of substitution is very less. That means you can substitute very little amount of labor for capital. है ना? So can I say that MRTS is the technologically feasible labor capital rate of substitution? Does this make sense to all of you? Yes? Is it fine? In the production process, given the production function, how can you actually, what is the possible substitution can you make? And if you look at the elasticity of substitution, in the numerator we have k by l. So actual में आप कितना कर रहे हो? So it is actual versus the possible ratio. That is what it is. So that means if I look at this measure once more, it is percentage change in k by l divided by percentage change in MRTS LK. Okay. So if I try to expand this a little bit more, if I just separate this part out, percentage change का मतलब क्या होता है? D of k by l divided by k by l divided by D of MRTS divided by MRTS. Okay. And this further can be written as D of log k by l divided by D of log MRTS. Okay, with all of you, any questions up till this?
Sir, how did we get the log? I,
Okay. In general, I think if I can just write a simple expression over here on this side, if I have an expression like dx by x, right? It is nothing but d of log x. Correct. Because if you use chain rule, derivative of log x is 1 by x into derivative of x is dx. So if you have a form like derivative divided by the variable, it is d of log x.
Okay, sir. Okay, thank you.
Okay, yeah. So that means since we have d of k by l, so in the numerator your k by l is your variable. So that means we can write d log of that variable, which is k by l. And similarly in the denominator, it will be d log of MRTS. Okay. And whether we are talking about the other elasticities that we have in economics, like elasticity of demand or everything, we can express them in log terms because both the numerator and denominator are percentage changes, right? So that is why both can be expressed in log terms. Any other doubts up till this much? Is it fine? Is it making sense? Okay. So now, if this is understood by all of you, now let us try to find out the elasticity of substitution of some production functions. Okay, let us take a simple one to start with. So the question is, we want to find the elasticity of substitution for Q is equals to A times L to the power alpha K to the power beta. Okay, the Cobb-Douglas production function. Let me show you one question so that it's easier for you all to follow. So given the definition, you can see you need log of k by l and d of log MRTS. So what we will do, we will straight away go for finding out MRTS because we know that MRTS is also a function of capital and labor. Okay, so for finding out MRTS, what we'll do, we'll take the MPL, which is del Q by del L. So A alpha L to the power alpha minus 1 K to the power. This calculations you all have already done, so we are not comprehending them once more. A beta L to the power alpha K to the power beta minus 1. MRTS is MPL by MPK. So that will basically become alpha by beta into K by L. Okay. Any doubts from anyone? Calculation? We have already seen these when we were doing the isoquant diagram, so we are not going in depth in the calculation. So now if you look at the expression, what we need in the denominator, we need log of MRTS, right? And then we'll take the derivative. So let's take the log. So log of MRTS will be what? It will be log of alpha by beta plus log of K by L, correct? And then you need to differentiate, right? So now if you differentiate it, this will be d of log MRTS is equals to alpha and beta are both parameters, so this will be 0 d of log K by L, correct? Is this step understood by all of you? Any questions on this?
No, it's okay.
Okay, with all of you, no doubts. And now if you look at the definition of elasticity of substitution, क्या होता है? K by L वाला डेरिवेटिव न्यूमरेटर में और ये नीचे. So bring this down. D of log K by L divided by D of log MRTS. Correct? And this by definition is your sigma. So that means for a Cobb-Douglas production function, sigma is 1. It's a constant value. Okay, got it everyone? Any questions? All right. So we can move on to the next question. So the next one, we want to find the elasticity of substitution for Q equals to
So,
A
so,
times, yes,
so what could be the economic interpretation of this? The elasticity of substitution is equal to one. It means that the feasible and like actual and the like supposed is equal.
suppose nahi, the
Like
technically possible feasible,
yeah, yeah, yeah.
technically possible substitution. हाँ,
Yeah.
exactly, correct. uh, L to the power minus rho plus 1 minus delta k to the power minus rho to the power minus 1 by rho, our CS production function. Okay. So if you followed the technique carefully, what I did for the prior question, log of k by l जो न्यूमरेटर में रहता है उसके लिए अलग से कुछ नहीं किए. We simply focused on finding out the MRTS and k by l actually came out. Okay. So here also we will be taking a very similar approach. So what I want you all to do is, let us first try to calculate MRTS, right? So MRTS का मतलब क्या चाहिए? We need MPL, which is del Q by del L, and we need MPK, which is del Q by del K. Can all of you quickly calculate these and tell me what's the expression that you're getting? Yes, anyone with the first one? MPL. So this will happen by chain rule, right?
A into minus 1 by E, then in
Minus
bracket,
1 upon rho. This entire third
this
bracket
is
will
called,
remain the same. Minus 1 by rho,
then minus
minus,
minus 1,
right?
then minus
Into
rho minus delta,
delta minus rho L to the power minus rho
minus 2
minus
minus 1.
1. Correct? Any questions from anyone? If you're not understanding the calculation, you can tell me. We can elaborate a little bit more if needed. We are doing chain rule over here. सबसे पहले माइनस वन बाई रो पावर का डेरिवेटिव, तो वो अंदर वाला कंपोनेंट सेम रहा, द पावर बिकेम माइनस वन, and then L, and then we went inside and did the derivative for delta into L to the power minus rho part. In the similar way, if this part is understood, for del q by del k again, starting में chain rule, तो A बाहर रहेगा, minus 1 upon rho, third bracket वाला part will remain the same, in, and then we will have 1 minus delta minus rho k to the power minus rho minus 1. Correct? So now for MRTS, what do you need? The ratio of these two. So ये part तो पूरा comma, it is exactly the same. So they will basically be cancelling out. So I'm not writing them anymore. And this minus rho
Mhm.
also will get cancelled. So you'll have delta by 1 minus delta L to the power minus rho minus 1 by k to the power minus rho minus 1. Okay. So if we just flip it around, delta by 1 minus delta, and this will become k by L whole to the power rho plus 1. Okay. Got it, everyone? Any questions? So what would be the next step? Can anyone tell me now?
Putting log on was
Log
one
what
side.
I
Yes. So it will be log of MRTS is equals to log of delta by 1 minus delta into 1 plus rho log of k by L. Okay. And then what next?
differentiate.
Yes. Differentiate it. So this will be d of log MRTS is equals to 1 by 1 upon rho d of log k by L. And then 1 by rho will come down like this, and this will be d of log k by L divided by d of log MRTS. So this is equals to sigma. That means for a perfect substitute, sorry, CS production function, this is 1 by 1 plus rho. Correct? Any doubts from anyone? Everyone getting this answer?
Yes.
Okay, all right. So now comes the interesting part over here. So
So
the
from here we
value,
can also check
yes, Divya, go ahead
by putting
from here.
so by putting rho equals to 0 here, then we can also check it is Bob Douglas.
Yes, exactly. That I was wanting to say. Perfect. That is what it is. And so last day, what I was showing you is that the CS production function is a very general. It can accommodate everything, right? And the very nature that it accommodates everything, that idea comes through the elasticity of substitution. Okay. Because if you understand CS का मतलब क्या होता है? Does anybody remember? It is constant elasticity of substitution. Okay. So the
So here,
idea or the, yes,
by putting minus one in a row, we can like make it as perfect substitute because the elasticity of substitution of perfect substitute is equal to minus n, like infinity.
it should be infinity, right? Technically speaking. है ना? That means the idea is that if you just look at this, okay, we are coming to all those cases one by one. If you simply look at this expression, sigma is equals to 1 by 1 upon rho. One thing stands very clear. अगर आपका रो जितना कम होगा सिग्मा उतना ज्यादा होगा. Correct? Because it is inversely proportional. And yesterday we have seen two examples for specific values of rho. कि अगर मेरा रो का वैल्यू -1 होता है, so now let us take case by case. Okay. And not only will we mention it, but also I have something to show you all from the diagrammatic point of view. So I'll just request you to just keep one graph handy and we'll draw it accordingly. Okay, so case 1 over here, we have seen that if rho equals to -1, this is the case of perfect substitutes. Correct? We have seen this from the production function point of view. And we find from this above expression that if rho equals to -1, then sigma tends to infinity. Correct? That is, higher sigma, greater is the degree of substitution between K and L in the production process. Correct? Higher the value of sigma, more is the level of substitutability that we have in the production process. Correct? And if we look at it from the isoquant view, एक substitute का isoquant कैसा होता है? It's a negative, correct? So let us say this is for tending to infinity. Correct? Case 2. What if I ask you, what if rho tends to infinity? Then what will be sigma? Can anyone tell me? If rho tends to infinity, then what will be the possible value of sigma?
Will be
Yeah. Sorry?
Zero.
0. Equals to 0 or tends to 0?
Tends
Tends to zero, sir.
tends to 0.
Tends to 0. तो इसका मतलब क्या हो सकता है? किस टाइप का प्रोडक्शन फंक्शन?
perfect complement.
Perfect complements. Correct. So that means if rho tends to infinity, then sigma tends to 0. And by this logic, this should indicate a perfect complement setup.
Because here we can't substitute anything.
Exactly. तो अगर यही same graph पे if I want to draw a perfect complements का isoquant, तो कैसे होगा? Basically we will have some वो dotted line और फिर एक L shaped curve. Correct?
Yeah.
Something like this. So this is for sigma tends to 0. Correct? Two extremes. Perfect substitutability, no substitutability. Okay? So this is for perfect complements. And the case that we have already seen in the last class, if my rho tends to 0, then what will happen?
Problem.
Yes, sigma will tend to 1 and we have seen it in both ways. Production function solve करके भी देख चुके, rho tends to 0 मतलब production function, and elasticity check करके भी देख चुके, it is production function of Cobb-Douglas. So this is Cobb-Douglas. Now tell me something by looking at the graph. Cobb-Douglas production function का isoquant कहाँ पे आएगा? Perfect substitute वाले से ऊपर, दोनों के बीच में कहाँ पे आएगा? Where should I place the isoquant for Cobb-Douglas? Because for Cobb-Douglas, sigma is 1, right? The more I'm going down from perfect complement to perfect substitute, elasticity is increasing. So that means the Cobb-Douglas one should be somewhere in between. Correct? Is it making sense to all of you?
Yeah. It would be between the 0 and infinity.
Yes, so this is the sigma equals to 1 wala case. Okay. Can you observe something from the graph? लेबर और कैपिटल का सब्स्टिट्यूटेबिलिटी जितना ज्यादा होगा production function will be more stretched out or more open, so to say, है ना, ज्यादा फैला हुआ होगा. And if the substitutability is very less, it will be more concentrated or more cramped up. Correct? So the elasticity of substitution can be anything between 0 to infinity, right? Those are like the two bounds. No substitutability mein sigma will be 0, and perfect substitutability mein sigma will tend to infinity. And for any other production functions that we take, Cobb-Douglas, I took one case, you can have quasi-linear and other possibilities of rho. So wo sub will be lying in between these two. Okay. So the idea is that the more spread out or more open the isoquants of the production function are, greater is the level of capital labor substitutability of the production function, or the more the concentrated they are, the lesser is the production function. Okay, so this is the idea. So that means, if simply speaking, अगर आपको कोई एक ऐसा ग्राफ दे दूं, something like this, let's say labor capital, you have for a production function, let's say, अच्छा sorry, कुछ ऐसा है, this is the isoquant for production function 1, and you have another isoquant, something like this, production function 2. So you can, just by looking at the graph, you can say, right, कि कौन सा क्या है,
Yes.
right?
Yeah.
Correct? So the more spread out, more is the degree of substitutability. The more concentrated, the lesser is the degree of substitutability in the production function. Okay. So that's the idea of your elasticity of substitution. And by changing the values of rho, you can basically end up getting different kind of production functions having different kind of substitutabilities. Okay. And note that one thing additionally that I want to mention over here, कि अगर आपको समझना है कि एक रो का different values के लिए production function कैसा होगा, then you can actually either take two approaches. Either you can simply check the elasticity of substitution, उससे आपको idea मिल जाएगा, or you can substitute the value of rho in the production function to check that. But as you saw in the last class, कि कुछ कुछ रो के values के लिए the calculation might be slightly lengthy. Okay, so I'll say you all can prefer the elasticity of substitution method, because in general हम लोगों ने formula निकाल लिया sigma equals to 1 by rho plus 1. अब रो का जो भी values हो डाल के देख लो, you will be getting the idea anyway if your concept is clear. Okay, so if you think so that calculation can be avoided at times if the question doesn't explicitly ask for it. Okay, clear with everyone? Any questions? Okay, perfect. So now let's move on to one more thing that I want to discuss today. Not a specific question as such, but an interesting property. Suppose we take the Cobb-Douglas production function. Okay, Q is equals to A times L to the power alpha, K to the power beta. Alpha and beta are positive. Does anybody remember how we interpreted alpha and beta for the Cobb-Douglas production function?
It is the
Yeah.
elasticity of production.
Yeah. For the alpha, it would be the MPL,
MPL, yes.
like into L, like total L.
Yes, MPL
by Q.
into U. Okay. I heard someone saying elasticity of production of what? Like elasticity of production of what? Can you repeat? Was someone was saying with respect to elasticity?
If it is alpha, then it is elasticity of production for labor. Then if it is beta, then elasticity of production of capital.
Elasticity of production of labor. Yes, you can say that. Like elasticity of production as in percentage change in output due to percentage change in labor, right? That's the
Yes,
interpretation that you mean.
yes, yes.
Yeah, you can say that. Yes, yes, yes. That you can say that as well. And I usually refer to it as share of labor in production. Okay, you can say your elasticity as well. It's fine. And similarly, beta is basically mpk into k divided by q, right? All of you remember this? Any questions on this? So this was basically the share of capital in the production. Okay. Now tell me something. If I write alpha plus beta, what would you interpret it? It will be basically the share of the factors of production in the production process. Correct? All of you agree with me? अल्फा इज
Yes.
लेबर एंड के इज कैपिटल, तो दोनों को ऐड कर देंगे तो टोटल शेयर ऑफ लेबर एंड कैपिटल, एंड टोटल शेयर ऑफ लेबर एंड कैपिटल का मतलब टोटल शेयर ऑफ द फैक्टर्स ऑफ प्रोडक्शन. एंड इफ आई लुक एट द फॉर्मूला, ये बन क्या रहा है? अल्फा प्लस बीटा will basically be mpl into l by q plus mpk into k by q. So that means it is simply mpl into l plus mpk into k divided by q. Correct? So I can simply write it as mpl into l plus mpk into k is alpha plus beta into q. Correct? What is alpha plus beta? The interpretation would be that, and alpha plus beta is also the degree of homogeneity of the production function, right? Correct? Remember this, all of you, of the production function. So that means this alpha plus beta can be greater than 1. That would imply IRS. Alpha plus
Right.
beta can be equals to 1. That would imply CRS. And alpha plus beta can be lesser than 1. That would imply DRS. Correct? All of you remember this? So
Yes.
that means, let's say if I talk of case 1, increasing returns to scale. Increasing returns to scale means alpha plus beta is greater than 1. So can I say in the case of IRS, this is what will happen? In the case of CRS, this is what will happen. And in the third case, in the case of DRS, This will happen, right? All of you, correct? Is it fine with all of you? Any questions?
Yes.
Okay. Now, what I would want you all to think a little bit, I'm not discussing this right away today. I'll just put this as a homework for all of you. Ki, what what might be the economic meaning of these things? Like what does these expressions tell you? आप कोई भी उठा के देख लो. Okay, maybe IRS, CRS, कोई भी एक उठा के, like ये जो expression जो है, so essentially the left hand side and the right hand side are the same, right? It is only we are having greater than, less than, or equals to, based on three situations. Correct. What does these expressions tell you? Okay. Economically, what might these mean, or economically or mathematically? What do these expressions actually mean, or what might these be? Okay. Just think about this a little bit, and I'll be taking this up in the next class. Okay. What might these mean? Okay. The economic meaning or the interpretability part of these expressions. All right. Got it, everyone? What I'm asking you to do? Any questions? Okay, perfect then. So that's it for today's class then, everyone. Stopping the screen share, you all can disconnect. Okay.